Between December 21st and 25th, 1989, an Arctic air mass penetrated southward across the continental United States, driving temperatures into the single digits Fahrenheit across the Gulf Coast and below freezing throughout Florida. The intrusion reached latitudes where municipal infrastructure had been designed without cold weather margins. Freezing conditions persisted for 48 to 72 consecutive hours in zones where annual freeze probability was below 10%. Municipal infrastructure across the Gulf Coast in Florida had been designed to ambient temperature envelopes that reflected historical norms. In coastal Texas, Louisiana, Alabama, and peninsular Florida, winter design temperatures typically ranged from 28 degrees Fahrenheit to 35 degrees Fahrenheit, with freeze events averaging fewer than 5 days per year and rarely persisting beyond 12 hours. Water distribution pipes were installed at shallow depths or ran exposed in unheated crawl spaces. Residential construction standards did not mandate wall insulation beyond minimal thermal resistance values. Electrical heating systems were sized for breathe-cold snaps, not sustained Arctic exposure. These design assumptions reflected climatological probability rather than absolute physical limits.
A high-amplitude meridional displacement of the polar jet stream allowed a deep trough to establish over central North America on December 19, 1989. Cold air originating above the Arctic Circle moved southward without significant moderation. Surface high pressure exceeding 1,040 millibars anchored over the northern plains, directing Arctic air masses southeastward across the Mississippi Valley and into the Gulf Coast region. The synoptic pattern prevented warm maritime air from the Gulf of Mexico from penetrating inland. By December 21, sub-freezing air had reached Brownsville, Texas, and by December 22, freezing temperatures extended across all of Florida. The trajectory was unobstructed by orographic barriers or warm advection patterns. Minimum temperatures recorded during the event fell 20 to 35 degrees Fahrenheit below long-term averages for late December. Tampa, Florida, registered 18 degrees Fahrenheit on December 24. Jacksonville recorded 10 degrees. New Orleans measured 11 degrees. Houston dropped to 7 degrees. Corpus Christi reached 12 degrees. These readings represented departures from December climatological minimums by margins exceeding 2 standard deviations. In many locations, the observed temperatures fell below the 1% annual design values used in engineering standards. Instrumentation networks confirmed that the Arctic air mass retained thermal integrity throughout its southward displacement, with minimal diurnal warming even under clear skies.
Freezing temperatures persisted for 48 to 84 consecutive hours across regions where historical freeze durations averaged 4 to 8 hours. Houston remained below 32 degrees Fahrenheit for 72 hours beginning December 22. Tampa stayed below freezing for 36 hours. Coastal Louisiana registered sub-freezing conditions for 60 hours. The extended duration allowed terrestrial and structural thermal reservoirs to equilibrate with ambient air. Soil frost penetration exceeded shallow pipe burial depths. Water within uninsulated distribution lines reached 32 degrees Fahrenheit and nucleated ice crystals. Thermal inertia that normally buffered brief freeze events was exhausted. Equipment and infrastructure designed for transient cold exposure entered failure regimes. Electrical demand surged as heating systems operated continuously. Peak loads in Texas exceeded forecasted winter capacity by 18%. Utilities implemented rotating outages to prevent grid collapse. Natural gas delivery systems experienced pressure drops as residential and commercial heating demand exceeded pipeline transmission capacity. Power plants encountered fuel supply constraints and equipment failures at sub-freezing operating temperatures. Transformers and transmission infrastructure not rated for sustained operation below 15 degrees Fahrenheit experienced insulation brittleness and reduced dielectric strength. Grid operators curtailed industrial loads and initiated emergency demand reduction protocols. Outages affected approximately 250,000 customers across Texas, Louisiana, and Florida during the peak stress period on December 23 and 24. Water distribution pipes installed above frost depth or in unheated spaces froze and ruptured. Municipal systems in Houston, New Orleans, Tampa, and Orlando reported thousands of main breaks and service line failures. Residential plumbing in crawl spaces and exterior walls burst as ice formation exceeded pipe yield strength. Water treatment plants experienced process equipment freezing, reducing output capacity. Fire suppression systems lost pressure. Hospitals activated emergency water reserves. Repair crews could not locate all fracture points until thaw initiated on December 26, at which point simultaneous ruptures caused system-wide pressure loss. Estimated service interruptions affected over 1 million customers. Boil water advisories remained in effect through early January as distribution integrity was restored incrementally. Ice accumulation on roadways and overpasses occurred as residual moisture froze under sub-freezing air temperatures. Interstate highways across Texas, Louisiana, Mississippi, Alabama, and Florida experienced closures due to ice and stranded vehicles. Municipal fleets lacked sufficient de-icing materials. Regional stockpiles had been sized for infrequent, brief freeze events. Commercial trucking halted across the Gulf Coast corridor. Airports in Houston, New Orleans, and Tampa suspended operations for 12 to 24 hours due to ground equipment freezing and runway ice. Bridge surfaces iced before roadways, creating localized collision zones. Emergency response times increased due to impassable routes. Traffic volumes declined by approximately 60% across affected metropolitan areas during December 23 through 25. Citrus crops in Florida sustained cellular damage as intracellular water froze and ruptured cell membranes. Freeze duration exceeded the tolerance limits of orange, grapefruit, and tangerine varieties. Estimated crop loss exceeded 30% of the 1989 harvest across central and northern Florida groves. Vegetable fields in South Texas experienced complete loss of winter plantings. Nursery stock froze in unprotected growing zones. Livestock operations reported animal mortality due to exposure and water system failures. Petrochemical facilities along the Gulf Coast shut down process units as instrumentation and heat tracing systems failed. Refinery throughput dropped by approximately 15%. Natural gas processing plants experienced freeze-offs in dehydration and separation equipment. Industrial water cooling systems sustained pipe ruptures. Municipal water outages eliminated sanitation capacity for hospitals, schools, and commercial facilities. Loss of water pressure disabled fire suppression systems during a period of increased heating equipment failures. Electrical outages interrupted communication networks, payment processing, and traffic control systems. Public transit in Houston and New Orleans reduced or suspended service. Shelters opened for populations without functional heating. Grocery supply chains experienced interruption as transportation networks remained impaired. Natural gas service disruptions affected residential heating and cooking capacity. Emergency services operated at reduced effectiveness due to road conditions and communication limitations. Restoration proceeded in sequence as temperatures rose above freezing on December 26, with full system functionality not achieved until December 30 in many jurisdictions. The National Weather Service classified the December 1989 cold wave as a top 5 Arctic intrusion event for the southeastern United States in the 20th century. Temperature records were established at 127 stations across Texas, Louisiana, Mississippi, Alabama, and Florida. The event marked the coldest December on record for numerous Gulf Coast locations. Meteorological analyses confirmed that the synoptic pattern allowed unmodified Arctic air to reach subtropical latitudes with minimal thermal modification. The temperature departures and geographic extent placed the event in the extreme tail of regional climatological distributions. Official documentation archived the atmospheric conditions, infrastructure impacts, and service disruption metrics. The event entered the climatological record as a reference case for cold air intrusion into non-freeze-adapted systems.